We'll do a few more examples of how to write these ionic compounds. We'll go a lot faster. Okay, calcium fluoride. Calcium's here, fluorine or fluoride is here, metal, nonmetal. We want to talk about charges. So calcium is in this column, which makes it Ca2+. Fluorine, fluoride is in this column, so it's going to be 1-. How do we balance these out? We got 2+ here, so I want to add another fluorine so that I have a total of 2- to balance out the 2+. 1 atom of calcium is balanced out by 2 atoms of fluoride or fluorine, so I'm going to write CaF2. All right. Magnesium oxide, go back to the periodic table. Magnesium here, oxygen here, metal, nonmetal, so it's ionic, so charges are important. So magnesium 2+, Mg. 2+, oxide, the word for oxygen when it has a charge, O. 2-. How are we going to balance out the charges? Oh, they're already balanced out. I have 2+ here and 2- here, so I don't have to add more of either one of the atoms. So I can just write MgO. Remember, don't write Mg1O1. Without a number here, it just means you have 1 atom. So that's magnesium oxide. And finally, strontium phosphide. Strontium Sr is right here. It's a metal. And phosphide is what we call phosphorus when it has a charge. So it's a nonmetal. Metal, nonmetal, charges are important. So strontium is in this column, which means that it's Sr 2+. Phosphide, phosphorus, is in this column, which means that it has a charge of 3-. This is like one of the examples that we did previously. Here's how we do it. We add another phosphide so that we have a total negative charge of 6-. To balance out the 6- charge, I'm going to add more strontiums, which have 2+ each. So Sr 2+, now I have 4+. Now I add another Sr 2+, and now I have a total of 6+. 6+ balances out the 6-. Now I'm going to write the chemical formula to show how many of each atom I need to balance out the charges. I'm going to say Sr3, 1, 2, 3, P, 1, 2. Okay, so that's how we write formulas for these ionic compounds. There's one thing that I want to say. Sometimes these formulas that you're writing are referred to as the formulas of binary ionic compounds. Well, you know why they're ionic, because we have a metal and a nonmetal in everything that we wrote. So that makes it ionic, metal and nonmetal. What about this binary part? Binary means 2. And every one of these formulas that we wrote have only 2 types of atoms: sodium chloride, magnesium oxide, aluminum, oxygen, lithium, oxygen, and so forth. We might have more than more than 2 actual atoms in something like Li2O3, but there are only 2 types of atoms, 2 elements in each of these. So that's why we call them binary. If this is all good for you, go ahead and move on with the videos. You'll probably want to check out the videos on writing the formulas for compounds that have transition metals, and then writing formulas for compounds that have polyatomic ions, and you can just keep moving ahead with naming these compounds.